Hello, hello. Thank you very much for joining us today. My name is Anna Chen Yun Tai. I'm a CEO and co-founder of Episcore. Today, I'm here with Trevor Ragno, Director of Construction Technologies. Hey, Trevor. And we also here with the Abigail Grace. She is also from our team and helping us make sure that everything technically is correct and recorded. So we're really happy to have you here today. And we also ask everyone to mute themselves. And if you have any questions, please post it in the chat. And then I will pick up the questions that we can address today. If we are not able or don't have time to address it today, we will send it by email later on. And so today, the investor webinar, and it's the goal of the webinar is to give you some updates and overview of our technology, our business plans, and also how the Start Engine works and how you can become a part of our journey by investing on Start Engine. And we also going to do these webinars twice a month. And next webinar, we will introduce more our team members. We have really incredible people recently joined us, and we would love you to know more about them. But today we just start, and we received your topics that you want us to cover. So today we're going to talk about the technology overview, our business plans, our plan to grow, also about all of the construction technologies, how the walls are insulated. Trevor Ragno is here to pour all of the knowledge we have. And also we're going to touch about the Start Engine and perks on Start Engines. So let me start with my presentation. So Trevor, do you see my screen? Everything is okay?
Yes.
Perfect. So first of all, this webinar today is just to give you our overview, and it's not something that you need to accept as a basement for your investment. If you have any questions and want to know more about our plans before invest, please read the Form C on Start Engine and all of the disclaimers. We are not allowed to give you any projections or any guarantees on returns, anything like that. So please carefully read all of the offering details on Start Engine before making decision to invest in us. So I'll start with the simple overview about the technology and specifically Episcore's 3D printing technology. So the technology is about how to expedite and improve the construction process. And just to be clear, today, the 3D printing technology is only about 3D printing the walls, and it's not the overall finished house. We still do traditionally roof, windows, mechanical, electrical, plumbing, and finishing, insulation, and reinforcement. However, starting with the automating the walls, we believe, and our vision that is the main foundation, how we can start really rethinking the construction process. We do understand that construction is very complex and a lot of processes are involved, and we also need to improve the overall workflow of the construction. And actually 3D printed, accurate, high quality walls allows us to do that. We can expedite and improve the secondary construction, as we call it, windows, roofing, mechanical, electrical, plumbing. We even can do some of the construction processes as we print. For example, we can drill the holes for the electrical outlets as we print. So this is it leads me to the question, to the answer about what all of the cost savings and how much does it cost to 3D print a house. It really depends on the on the project, on the location, on the floor plan, and what exactly you want to build. Do you want to build an affordable house, or do you want to build a luxury house? So, but for all of these scenarios, the cost savings can be from 10% to 30%, 30%. Maximum cost savings may be achieved on the simple, affordable housing. However, it's still going to look very decent with the high quality, and it's going to be durable concrete house. So how we can actually save costs is the better quality of the walls. That allows us significantly reduce the cost on the finishing. Specifically, our 3D printed walls have the best quality in the industry. That means that we need to spend way less materials like a stucco or plastering, for example. We even can print the walls right away. This is more affordable solution, but still some people even prefer it for the luxury style. It's more like a industrial style. And we also can add a lot of value engineering, meaning that we can get rid of dry walls, because we can install the insulation in the cavities of the 3D printed walls. And also because of the precision of the 3D printed structure, roofing, windows, and all of the secondary construction can be significantly improved and expedited. So this is about the costs. Also, obviously, we increase the overall construction time, and we can 3D print and build houses with the consistent quality, consistent budget, and it's also going to be all the time predictable. Sometimes you can hear that people saying like, oh, I can 3D print, I can build a house in 2 months, and I can build a wall structure in 2 hours. I think it's possible. I know people that they sound really, really realistic saying that, but question is it possible for one house, or is it possible to keep doing this for 1,000 houses? We are here with this technology to make this process scalable and not just the success for one-time project. This is the consistent and scalable solution for thousands of houses. So this is why we can say that, yes, we can really reduce the construction time from 7 months. This is standard for the mid and small companies, not for the national home builders. We can reduce it from 7 months to 2 to 3 months overall finished house. And again, it comes with the 3D printing technology and all of the benefits that involved in the 3D printed walls. It's not just I can 3D print walls only. It's all of these additional benefits and value engineering coming with the 3D printed walls, specifically for our technology. And also, we are not the construction company. We are the technology provider for construction companies. So our goal and our mission, why we exist, is to empower the home builders how to increase productivity, build faster, cheaper, I love saying more affordably, because our houses looks durable and really decent. It's not cheap looking, I would say, and how to really scale this and consistently deliver this result for one house or 1 million houses. So now really quickly about the robots that we have. Frank is the printer. So the Frank is mobile and portable and very easy to transport. And you can see that it's pretty compact. When we say compact, it's not something that can put in your purse, for example. It's really compact compared to the human size, because other companies and other printers, they are huge. Compared to them, we are really compact. Frank can print up to 2 floors. This is how you see he's finishing the walls of the first floor. You can see the quality, you can see how it lifts up. This is how it compared to the operator. It's actually Nikita Chenyuntai, the inventor and CTO and co-founder of the machine on one of our construction projects. This is what we mean saying that it's very easy to transport. So Frank actually can fit the flatbed trailer. And how we can 3D print 2-story. Hypothetically, we can 3D print 3 floors. But now we only tested for 2 floors. So, for example, the same as we did in Dubai. We installed the precast slabs, and then we put the printer using crane on the second floor, and we continued printing the walls of a second floor. However, the walls were very tall. It was 4.5 meters tall, and it was much higher than the printer can print from like when stationary. So here on the left, you see that we put printer just on a very simple metal frame pedestal. And this is how we extended the printing height to 4.5 meters. And we can do the same for the house that you see on the right. Like alternative way, we 3D print the entire height using the metal frame, and then we install the wood joist at the slabs between the floors. Frank is also very compact. It's designed to go through the doorways. So when you completed printing a house, Frank just driving through the doorways. About the material, so the material we use, and we developed it from scratch. It's a special concrete mortar, but it consists in about 90% cement and sand, and about 10% it's a special components and accelerators that makes the material extrudable and durable and suitable for 3D printing. And the magic, or like the secret sauce about that, it's what exact components you use and what the ratio between them. Like it's basically the recipe of the material. We spent years to crack the code for the perfect and really advanced material. We're really proud of it. And the quality of our material also allows us to print walls with the exceptional quality. But again, all of the components that we use, they're not toxic, they're not fancy or something like a prohibited. We use the components and accelerators that already used in the concrete industry. Again, the proprietary part of that, what exact components you use and how much you need them in your recipe to achieve the best result and the extrudability, I would say. So now Gary is a little brother of Frank, and it's our proprietary piece of equipment. It's a mixer and pump machine that mix the dry material, the 3D print material, with water and then send it to Frank. Gary was designed after our experience in Dubai when we used the standard existing plastering machine. That was a nightmare. We realized that it's not the way how to continue this technology. We have to create this specialized mixer machine for that, because it wasn't any solution for the 3D printing technology. Material is really sticky, and material is, it's different material that we use. So we had a lot of clogging, a lot of problems on Dubai project, but we completed that project. And that experience showed us that, yes, we need to create proprietary mixer if we want to make this technology really scalable and make our customers happier when they use it. Gary also compact, also mobile, and mounted on a trackable, on the Caterpillar tracks. So it also can be moved easily just using joystick. For our equipment, you don't need to have cranes, forklifts, or pallet jacks. You even don't need a lot of people. You basically need one person to operate the printer, the Gary and Frank. And you need one person to transport it and to deploy it on the construction site. Equipment is all the time assembled, so you don't need to do all of the screws all the time. You just use the joystick to wheel the robot out of the trailer that you see here. And this is our recent piece of equipment we finally got. It's an enclosed hydraulic trailer. It lowers to the ground, so it's not tilted. So you easily use joystick, and printer, Frank and Gary just easily drive out of the trailer. And you just need to use the standard Dodge Ram 2500. This is everything that you need to deliver our 3D printing equipment to the construction site. This is something that we're also really proud about. And the philosophy behind our technology was how to create the robotic solution that can be very easy to use, to operate, to deploy, so that it will be scalable. And the last member of our 3D printing family, it's Mary. Mary, it's a trailer that transport the 3D print material. 3D print material is a dry mortar. It comes to the construction site in a dry form. Then you plug in all of the hoses to Gary. Gary mixes it with water and immediately send it to a printer to extrude. Mary is pretty standard piece of equipment. We a little bit redesigned it for our purposes. Here you see Nick, CTO and inventor again, on the way to inspect the material inside the Mary. And this is just the videos to show how it actually looks in reality. This is the old trailer we used. It was tilted, but still pretty good solution. And this is the building in Dubai, which is the Guinness World Record as the largest 3D printed building on Earth. And that was possible to make because of all of the mobility, transportability of our robotic solution. This is the building again. And now I'm passing the presentation to Trevor, who's going to cover all of the technical questions and matters about the construction technologies. Thank you.
Thanks, Anna. Yeah, my name is Trevor Ragno. I'm the Director of Construction and Building Technologies, and my background's really in especially the commercial real estate and development space. I've developed office, retail, multifamily, self-storage, even data centers. And while in that process, you tend to see a lot of the common issues that are found on the construction site. A lot of these things, when you compare, for those who aren't familiar, kind of traditional construction to 3D construction, it's really common to see human errors on the job site, and those carry costs with them. Some of the materials and some of the time that was spent doing the work that needs to be replaced. And with a robot, you really are able to follow the plans to a T. And that level of quality really helps reduce the human error and also reduce the kind of unforeseen costs that might happen on the job site. Also, you see wood homes all over the place, but as somebody who is building or selling a house to someone, you really want to make sure that can withstand the test of time. And when you're building with materials that are flammable and materials that are very prone to moisture infiltration, mold, mildew, rotting, and even things like termites, you see that those homes are not really built to last for generations. It's not like concrete that's fire resistant and it's moisture resistant, and it's also really, really strong. These are all great things in a place like Florida, where our company's based out of, where we have things like hurricanes and big flood events. Also, in the construction industry, you always hear about delays. Anna mentioned earlier that the average home right now, U.S. Census Bureau says it takes about 7.3 months to build a typical residential house. If that's a custom home, it's up a little over a year, 12.3 months. Right now, the average delay that's seen on these construction sites is a little over 200 days. Now, one, a 3D printer is obviously much faster than a typical block crew, but also, and just as importantly, before you ever make it out to the construction site, down to the minute how long that printer is going to have to run to complete the walls of the home. So that allows you to not only act more quickly, but also be able to have a little better control over the scheduling process. Waste is a big issue on the construction site. Construction and demolition waste, it's the largest to landfills. But one of the big problems is that you just purchase those materials. You purchase those plywood or those studs, and now you're basically cutting it up and sending a large chunk of it right out to a landfill. That's one of the beauties of 3D printing. You're only using the material that you need. So you aren't wasting money just sending it to a landfill, but you're also helping the environment. It's all electric, and concrete materials like this are all fully recyclable, including the steel reinforcement that's inside of it. And lastly, really, we've seen a big kind of almost a new era for architectural design freedom that's getting ushered in by this technology. Historically, we build a lot of kind of boxes, square homes, straight angles, sharp corners, because that's really easy to build manually. And a lot of the materials come that way. It's much more expensive to normally build, let's say, a curved wall. But with a printer, it's cost just as much as building a straight wall with hard corners. In fact, it might even be a little bit more affordable because you're literally, cutting the corner. So now that we've kind of covered the bases between why 3D printed construction in the first place, show you a little bit of Frank here. I know Anna covered this pretty well, and we talk about these nice sweeping corners, but we can also make very precise and sharp corners with this machine, thanks to this smoothing spatula we have on the outside. We've talked about printing buildings in multiple sections, and being able to do that with that good, smooth, consistent quality, there's really a lot of advantages to that we'll touch on in just a minute. So between the different types of printers out there, there's a few out there, there's robotic arms and a few others, but the biggest category of printer that you see, besides the OptiScore printer, are really these gantry printers. If you aren't familiar, they're essentially like a CNC machine that's just scaled up, or like a desktop printer that's normally used for plastic, but just put on steroids and made absolutely massive. Now, these printers are common in the industry, but there are some drawbacks to using them. One of which is pretty obvious. Anna touched on it earlier, that these printers are massive, so they take really big equipment to transport. Oftentimes, one or even multiple semi-trucks. I believe the last printer that was just shown there takes 3 different semi-truck loads to deliver. However, the OptiScore printer, if you have a pickup truck like most contractors do, and a trailer like most contractors do, then you can already take the printer, the mixer, and all the equipment you need to get ready to start printing out on site. And that's something that really helps with affordability on the front end. Once you get to the site, a lot of these larger gantry printers, they require heavy equipment to assemble. These are things like construction cranes and telescopic forklifts that, of course, cost money to rent and take up space out on the site, but it also adds a significant amount of time from the time you arrive on site to the time you can begin printing and ultimately deliver the home. This is often, it could be a few days or it could be a few weeks, but you're not going to see a gantry printer that can be set up by a single person with no additional equipment and no assembly required. And that's exactly what we've designed the OptiScore, the printer Frank, the mixer Gary, this whole combination to really do. Now, operation. So once you get rolling out there on site, you'll notice when you look at some of these other printers and some pictures or images of them operating out on site, you'll notice that there's sometimes larger crews associated with them. There might be a crew that's monitoring the printing and the mixing and the finishing. And well, the whole idea of 3D printing is to help, reduce our reliance on construction labor, because there's such a massive shortage right now. It's so hard to find construction labor, but there's still so many houses that are needed. So if you're trying to fill that gap, adding just as many people or more to the site with one of these gantry printers, it's not really helping to solve the problem. That's why we have a printer and a mixer and even material delivery like a bulk truck that are all working in harmony. They're all communicating with each other. That way, the operator doesn't really have to do very much, and we can reduce the number of operators that are there. kind of frees them up to do other more productive things on site that we'll talk about again in a minute. And one big advantage here is the scale. So if you're printing with a gantry printer, you can only print inside the box. So a bigger home means a bigger printer. And there's not really an ability to print in multiple sections by moving that large gantry printer, simply because the mechanics wouldn't allow that large boom to get right up against a neighboring home or a neighboring print section. But our printers specifically designed to print buildings of unlimited scale. There's essentially no limit to the size of the building you can create, except for maybe the size of the plot of land that you're building on. And that's one big reason why we were able to print the largest 3D printed building on Earth. This building in the back, I know Anna mentioned 4.5 meters earlier. That's about 31 feet tall. It's about 7,000 square feet. And although it is only 2 stories, at 31 feet, that's around as tall as you'd see walls for a 3-story home here in America. Again, we've not printed a 3-story building just yet, but at least in this use case, you can kind of see we have tested up to 31 feet in print height there. But printing in multiple sections is really, really important. And this is going to kind of help explain that just a little bit. So the printer's moving into section 1 and will move over to section 2. And as it begins printing, you can see there's kind of a joint between these two sections where they're coming together. This is something that is actually required with typical, let's say, concrete masonry construction, concrete block home. You can see the home kind of being finished out here. Those joints are called control joints or abutments or building movement joints. Essentially, they're designed to prevent cracking. And again, they're required by building code. Normally, a masonry crew builds the block wall, then they get a cement saw and they cut those control joints in. But by strategically planning our designs here, we're able to just automatically incorporate those control joints. Another thing you might notice is that you're able to do a lot more when you're printing in multiple sections. You're able to do things like, let's say the printer just finished up section 1 and it's starting to print section 2. Well, now as an operator, you're able to start cutting in outlets in section 1 and adding insulation and adding reinforcement and roughing in, holes for plumbing and a whole list of things that normally you'd require a different crew to do or would be done after the masonry crew left. So all of these, electrical rough-in, plumbing rough-in, insulation, window rough-in, all these things can now be done by fewer people and fewer crews and really all at the same time while printing's occurring. So it's not that you're necessarily needing to reinvent the entire home to print these buildings and save time. You're essentially doing the same thing, but just through the efficiencies that this kind of equipment brings to you, you're able to kind of shorten the overall construction time and also help save money in that process. Another thing that's interesting about this is that since we essentially are printing in these multiple sections, you're able to also have multiple printers operating at the same time in the same place. So for example, you can see these 2 printers operating to build that same home at the same time over in the top left. Or over here in the bottom right, you can see multiple printers, all, let's say, owned by the same builder, who are building multiple homes kind of side by side next to each other. This is just another thing that lends itself to what Anna was talking about earlier with scalability and being able to, grow your business by having, instead of, 1 printer, getting 2 or 3 printers and being able to significantly ramp up your production and delivery of homes as a builder. So we have kind of taken a different approach than any other construction 3D printing company in terms of what we're actually printing, the walls themselves. A lot of companies try to differentiate themselves by, the print pattern that they're making, but the unintended consequence of that is that, it's really unfamiliar. How do you design for that? How do how do I install a window? How do I attach a roof? How do I do all of these things? Because it all seems to be new. But, in our opinion, the concrete block wall, it's really a gold standard of construction. So why reinvent the wall when you can make the same great the same great homes that have been being made and that everybody already knows, but just do that faster and more efficiently and more accurately. So when we think about it, these concrete blocks have been made by machines, just like our 3D printed walls. But those concrete blocks are made by a machine, a factory, and then manually assembled out on the construction site. We make the same concrete block walls fully assembled right on the construction site. And of course, it comes with those benefits that we spoke about earlier. So when it comes to permitting, I know this was before I really got involved with APISCore and saw how the permitting process looks when you're getting a building through approval. I expected there to be a lot more hurdles to go through, but surprisingly, we've done this in multiple states across the country. We made the first commercially permitted 3D printed building in America. And because we copy concrete block construction, what we've noticed is that it just makes a lot of sense to the architects, the engineers, and people at local code enforcement and building departments. So, for example, here on the left side, you can see these two walls. I know they look similar, but on the left side, we have a standard concrete block wall, and on the right side, we have a 3D printed wall. Now, at first glance, you can see that these are very similar, if not really identical. When you're thinking about, okay, well, how do I attach this wall to the foundation? Well, with a concrete block wall, you have these vertical dowels that go into the slab and connect in. And, you have the exact same thing here. You have reinforcement in the wall. The spacing of that reinforcement's the same. The grout you use in the cavities, the ladder wire, the bond beams, how you connect to the roof. Really everything is identical to how you would do this with a concrete block home. So, for example, let's say you had a set of construction drawings for a standard concrete block home, maybe something made by one of the big builders. You found this set of documents online. Well, in a matter of an hour or less, an architect and engineer are very easily able to just convert that set of plans for a standard concrete block home into a set of plans for a 3D printed home. Just kind of like you see on the right here. This looks identical to a concrete block wall, but if you look closely, you'll see a 12-inch extruded concrete wall is for a 12-inch wall, or we do 8, 12, 10, same as all the concrete blocks. And you'll see that the line here is kind of squiggly as opposed to being kind of vertical and straight. Really, that's the big annotation change. That's everything else is identical. We've had some really great third-party engineering studies published and shown some IBC compliances. Some of those are listed down here, but if you're interested, we have there's some of these documents published on the NFPA's website, and I'm sure we can share a link to that just after. So I know copying a concrete block may be the only way to make 3D printing sound boring, but in reality, I know everybody thinks of this block on screen as a concrete block. That's typically what we see. However, there's actually a lot of different types of standard concrete blocks used in the industry. So by copying concrete block building code, we're able to mimic not just the concrete block that you see up here, but a whole list of other concrete blocks, only a fraction of which you see on the page here. So let's say a mason is building something like a curved wall. Now, not just any mason can come and do this. It's a very specialized skill. It takes significantly longer and it's much more difficult to do, especially if you're doing it accurately. But we're able to build really amazing walls, even things like you see on the right there, this kind of parametric wall, using the same material, using the same machine, using the same operator, and doing this in essentially the same amount of time as just a simple straight 3D printed wall. So by copying that standard concrete block design, we're able to make design easier, make permitting easier. And then when you're doing that secondary construction, those tradespeople don't really need to be re-educated. It's very simple to do something like installing a window because it's really identical. This is what we talk about when we're saying secondary construction. It might be the reinforcement or the insulation or a roof, windows, doors, mechanical, electrical, plumbing. All of these other things are done identically. So on the bottom right here, you can see a sample wall. This is a 3D printed wall, and it has some electrical conduit and outlet in here. There's reinforcement, and there's plumbing, and there's insulation. And if you take a standard concrete block and set it on top of this sample wall, all of the webs match up perfectly. So it's very easy to understand how these two things are not just from a design perspective and a code perspective, they're all governed by the same concrete block building code and designed in the same way. But those secondary trades, you aren't needing to retrain people. You can still, use the same contractors that you've known for years if you're a builder, without having to go through the headache of retraining and learning all of these things. In most cases, there's questions, and everybody has these questions, and it makes sense. If you think, how would I attach a roof? The default answer is essentially in the exact same way that you would for a concrete block home in the same area. Or how often do I need to reinforce it? Well, in parts of Florida, it might be 2 feet on center, and other parts might be 3 feet on center for concrete block. Well, you do the exact same thing in the same area for a standard 3D printed block home. All of these things we also talk about in our online courses, but people kind of also wonder on the design side from the architecture, if you want to make something really cool, what do those design tools look like? Well, we've also developed some really cool plugins for the most popular softwares used by architects. These are, AutoCAD and Revit primarily. This allows you to just take a standard floor plan and in a matter of minutes, very easily convert this to G-code. Now, Frank, he doesn't speak English because, well, Frank's a robot. He speaks geometric code or G-code. And you don't have to be a coder to design any of this. It's as easy as simply, drawing lines for the perimeter of the home and using our tools to generate a path and export that so you can even test it in our simulator. On the bottom right here, you can see what that simulator looks like. It's identical to the printer's user interface. So when you're out in the field and you're controlling Frank, it looks the exact same. And this is how we're able to ensure that before we ever go out into the field, we know how long the print's going to take, we know how much material is going to be used, and we can verify that the actual G code that we're using out there is going to work really well the first time. So to learn more about this, again, we have APISCore University, and feel free to go online and check that out. And we also have some videos even about this design process that are on our YouTube page. So I think we're just about finished up on this section. I don't want to waste anybody's time here. So I think we're ready to go ahead and jump into some questions. So I'll stop sharing my screen and I'll pass it over to Anna to start kind of looking through some of the questions you've been sending in, and we'll do our best to help answer those. Thanks so much.
Oh, yeah, I actually have been answering a lot of questions in the chat. So I think one of the question that it's better you to explain in more details. It's how our 3D printed houses can be resistant to hurricanes and earthquake, and specifically in the Florida. So that was the question that I think you better to address.
Yeah, that's a really great question. Hurricanes and the flooding that comes along with them. Flooding, it's the #1 cause of property damage and one of the most destructive forces Mother Nature throws at us. Thankfully, the concrete block homes that are being built in Florida and all throughout the Southeast are here to help cope with that. And by copying this concrete block construction, we're able to show and meet those exact same performance criteria and standards. So in that NFPA document, we might be able to post a link to it in the chat here. If you just Google APISCore NFPA, you can see a lot of the testing results for things like this. And just like concrete block homes, which are resistant to Category 5 hurricanes, these 3D printed walls also are resistant to the same winds and water as another concrete block home, for example. Another thing to mention on this, though, is that part of your ability to resist wind in particular is, of course, the structural stability of the home itself. And again, we meet or exceed all of those design requirements and engineering requirements. But there's also kind of a more architectural view of how to cope with wind. So curved walls are able to kind of help deflect wind around a home structure, whereas a flat wall, when wind kind of hits it from the side, it only has a few places to go. It can't go down into the earth. If it's a big flat wall, it has kind of trouble going left and right. So up, kind of right up into your roof is often where it goes. So when we see roofs being lifted off of homes, from a lot of the, I'm sure seeing throughout this last hurricane season, a lot of this ends up on the news with different homes that are being built here. By designing a home that helps divert the wind around the home, you're able to better cope with some of those forces and help redirect wind into areas where you don't have damage to other systems besides the wall, things like, windows, doors, and roofing systems. Earthquakes is another great example here too. So in this building in Dubai, a lot of people don't think of Dubai as a very seismically active zone, but I mean, it's on the Zagros fault line in the Arabian Peninsula. Their seismic activity in the area where we built this is right on par with California. So we had to do a lot of testing and prove that the 3D printed walls we're creating are earthquake resistant. And we've also built another house in Missouri where you look at a seismic map of the US and you see California kind of lit up on the West Coast, but then right in the heart of the US in Missouri, you see it's a very seismically active area. Again, the way that these things are able to be coped with this or concrete block designs is through those control joints, those building movement joints. So homes are designed by default by normal concrete block building code, and as we 3D print them, engineers will spec this out to kind of conform to whatever the local geotechnical conditions are, whether you're in a place where your soil conditions require a different slab for a concrete block home and for ours, or whether they're it's more seismically active, or whether you have either very cold or very warm climate. All of these things, there's building codes for concrete block construction in every country around the world. So by simply following that standard code for that area, we're able to cope with whatever Mother Nature really throws at homes in that area.
Thank you, Trevor. I'm going to jump to the more like a business overview, but we still have some technical questions, so I think it's better to address them before we transition to the business discussion. So one of the question, I'm going to quickly address them: how to get on the waiting list to get my house built. So we used to have the wait list with the 200 non-refundable wait list fee. So we're going to start doing this again. So this is how you will be able to place yourself in the wait list. So basically, make sure that you signed up for our newsletters. This is where we post all of the information about that. And some of the questions also about how I can get my house built. So as I said, we are not the construction company. We sell and provide our technology to construction companies. So we started sales this month, and it was a really impressive and promising interest so far. So we hope that we're gonna make first sales this year. And lead time for our machine to fabricate and build the machine, it's 8 months. So realistically, end of this year or early next year, this is when the construction companies, the first construction companies, will start using our technology. We don't know the exact state as of now, but once we have them, we will publish this information and this customers and users of our technology on the website, and then you can reach out them directly and ask them to print your house. Maybe at that time they're already going to be assigned to the different projects they have, because our customers are the developers, construction companies, and mid-size and small-size companies. Maybe they will not be able to take your order right away, but you can actually start at least talking to them and waiting for them. Then the question about if we can add plastic, like recyclable plastic in the material. Yes, that's possible. However, as of now, we use the standard cement-like material because it's already very well established in the industry, the material. It's much easier for all of the building codes and adaptation, the technology in the industry. However, we do have the roadmap for the technology development and material development. We already started working with the geopolymers materials. Geopolymer, it's not plastic, it's actually concrete, but without cement. So it looks like concrete, it's much stronger, it's a very fire resistant material, but it's actually used fly ash instead of cement. So we do have plans how to transition to cement-free materials to decrease the carbon footprint in the industry. Then if you want to know price for the equipment, we will provide the contact details of Milton Kobus. He recently joined us as a director of sales, and he will be happy to speak with you about that. Yeah, so houses in Orlando or if we can print a house or we work with developers. Yes, we work with developers and home builders. They are our customers. However, next year we're going to do, or actually this year, we're going to do 8 pilot projects with those early adopters and home builders. So yeah, the time frame when our technology will be available approximately early next year. So I think that's it. So we have the wait list to print the house only because we already launched the sales of the equipment. So you don't need to join the wait list for the equipment. You only need to join the wait list for the house if you just want to have a house. If you want to buy the equipment and you're the home builder, you need to reach out to Milton Kobus. The printers are manufactured in the United States. And we only located in the United States. We're the American company, and we have our manufacturing capabilities in Melbourne, Florida. It's a Space Coast, and we're going to expand our manufacturing capabilities this year to meet the demand for the inquiries for the equipment we have. Yeah, so we offer printers for sale worldwide. And with the sale, it comes the warranty, technical support, remote technical support, the entire package. Again, like if you're interested, please reach out to Milton Kobus. You also can call our phone number placed on the website. It comes to Abigail or to Milton Kobus, depending on what option you choose. So about the original in-house investors and the perks. So the perks that we offer on Start Engine, they only available for investors on Start Engine. However, if you have any questions on that, if you're existing investors on Regi Plus, please contact Abigail, and we will double check what exactly we can do for you. So these are all the questions in the chat, and I think now I'm jump into the business discussion. So does it work?
Yep.
Or do you see it? Okay. So now it's more about our plans and how we position ourselves with what our vision, how to go to the market. And again, it's just ongoing discussion. It's not something that we guarantee to happen. I just want to make sure and clear that please read all of the disclaimers and Form C on Start Engine, because that's the information that you have to read before making investment decision. Here, it's just our ongoing internal discussion and what our plans that we want to achieve. So our business model is we sell or lease out the equipment to construction companies. We also supply and sell our 3D print material. or we also going to work with the authorized producers and manufacturers of 3D print material. This is something to increase scalability and also offer a variety of the options for the material. But 3D print material has to be authorized by us to make sure that the equipment going to work correctly and it's not going to be any damage to the equipment. Because the 3D print material is a big part of the successful product and successful use of the equipment. Raw material can easily damage the equipment, all of the hoses, or the result, the 3D printed walls will be very ugly. So if you don't want to have it, it's better to talk to us first what material you want to use, and we will check it if it works or not. However, you still will be able to use the material you want. This applicable for the customers who go in to purchase the equipment this year. We also make money on construction technologies because we are the construction technology company. And we already have a lot of technologies related to the value engineering, such as insulation, everything that Trevor just covered. And we also already have the roadmap for the technological development for the secondary construction, how to improve the installation of the roof, of windows, of everything. So again, we think about the construction as a process in a whole, not just as a we created the fancy technology how to extrude concrete sausages. No, it's not about us. We really think about the big picture and how really rethink the construction. And also we make money on training, technical support, and surrounding services, something like a G-code generation, our online courses, we already make money on it, and the seminars as well. And also, if you're interested in joining our seminars in February, we highly recommend you to secure your spot right now. We will send you the link after the webinar. And to support our business model, we already have 117 letters of intent from construction companies who want to use our technology. And these letters of intent we received from the thousands of people who we talk, or like somehow to communicate and pre-screen them. And we signed these letters of intent with the companies who we believe can be a good fit for us. So it's not just the random letters of intent, just to be clear. And now we are going to start working with them to convert them to the sales agreement or leasing agreement in the future. Before, we didn't want to do that because we wanted to make sure that the technology and product is going to be perfect, right? Now we feel very confident that the level of the technology that we created is ready to go to the hands of early adopters. Before, we really wanted to make sure that something that we're going to offer is going to be a really good product. And our company is all the time about how to create the best product and how to provide the best customer experience for those who use this product. And also we launched our sales this month. It was really strong demand. We already talked with the more than 15 or like 20 companies, and it's all the time growing list. And we already have meetings lined up for next week. People going to come see the machine and talk to us, and looks pretty interested in purchasing the equipment. So this is really exciting time for us. And again, like our plan, where we want to be in 5 years, by 2027, is to have at least 400 printers in operation. And those 400 printers will be able to extrude the amount of material to 3D print about 20,000 houses. So this is also a pretty conservative plan. Of course, we don't set it as a bar for us or like as a limit, but this is something that we believe we can achieve, and this is where we want to be in 2027. But of course, we're all the time trying to exceed our plans and expectations. And plans for this year, 2023. So this year it's very, very important for us and really critical, because this is the time when we're going to build at least eight pilot projects with our early adopters. Early adopters are the construction companies who already talking to us to purchase the machine or want to purchase the machine after we do the pilot project with them. And they also invested in our company, or they have been with us for a really long time. So we qualified them for a pretty long time. So we feel confident in them, having them as our early adopters. So these are the projects that we're going to 3D print. First project gonna be our model house in Melbourne, Florida. Hopefully, if everything going to be according to the plan, we will be able to start printed in May, maybe June. And for those model house, the investors on Start Engine who eligible, who invested the specific amount of money, they will be able to come and see the live printing of a house or stay for a couple of nights in the 3D printed house. And as of today, we're going to have pilot projects in Florida, Louisiana, Alabama, Georgia, Texas, Waco, and maybe Austin, maybe we're still in the discussion, California and Montana. So this is really, again, exciting time, but still at the same time, very critical. And it requires a lot of hard work for us to achieve this year. And if we achieve this year, 2024, that's going to be the year when we achieve what we want, right? Everything that's having all of the customers with our 3D printers and have them provide 3D printing services. So now about the sales. As I said, we already started sales of the equipment. Really happy about that. And if you want to learn more about the pricing and become the customer and purchase the equipment, please contact Milton Kobus. He is our director of sales, and he will be happy to walk you through the process. So now quickly about Start Engine. So Start Engine is the platform for equity crowdfunding qualified by SEC. Right now we raise money only through them, and we already have 509 investors, at least it was 2 hours ago. It all the time changing. And we also have 250 investors from the regulation A+ we did before Start Engine. So as of today, we have almost 800 people who joined us as investors. We're really, really happy about that. Thank you very much for being with us and believing in what we do and believing in our vision, that it really means a lot to us. About the investor perks, depending on the size of the check, you can receive free access to online courses. You can visit the live printing of a house. You can stay in a 3D printed house. You also can have a Q&A session with Trevor Ragno. So please read all of the details about that on the Start Engine. And if you're, again, existing investor, just reach out to Abigail and we will double check what we can do for you. Timeline. So as of now, we have our equity crowdfunding till end of February. Maybe we will pursue the extension, maybe not, we don't know. So the timeline can be extended, but it's not for sure yet. And investing on Start Engine, you can do it online. It's very easy and straightforward process. You can purchase our shares online. There are a couple of questions about your net worth because it will define how much you can invest. And if you have any questions about the Start Engine process, you need to reach out to Start Engine customer support. So this is it from my side. Stop share. So now I'm going to go to the Q&A and see what we can address, because we already almost finished with the time. What other countries do you have positive traction concerning contracts? Is Africa the most promising source of future investment at this time? So it was Africa, Europe, Canada, Australia, and Latin America as well. So it's basically from everywhere. I wouldn't say that the Africa is the most promising source, but we do have a very significant interest from there. What is Abigail's email? Abigail will put it in the chat. Oh, already done. Okay. You also can call on the phone on our website and you can talk to Abigail. So I think that these are all of the questions. And so we don't need to send you anything by email, which is good for us because we're really slammed and busy. So yeah, thank you very much for all. Really happy to have all of you attending our webinar today. We will send the recording today after this webinar. And Trevor, thank you very much. Feel free to say anything you want to wrap it up.
Yeah, thanks so much for listening to our presentation here today. I know everybody's busy, so I think I will just keep it short here and just feel free to reach out to us if you have any questions. Thanks so much.
Thank you. Bye-bye.